Hello everyone, my name is Munaimin bin Munjur and I will be presenting to you about our final project for high performance and parallel computing. The title of our project is Parallel Image Processing using Google Cloud. And these are my team members, Muhtasim Abeed and SADIK Mahmud. So let me give you an introduction to our project. Google Cloud's distributed computing capabilities and resources enable picture filtering, augmentation, and feature extraction. This application utilizes parallel computing and Google Cloud scalability to handle numerous photos, simultaneously reducing processing time. Computer vision, medical imaging, digital photography, and video processing heavily rely on image processing. Conventional image processing techniques can be time consuming and computationally expensive. Therefore, parallel computing and the scalability of cloud based systems such as Google Cloud addresses these challenges by distributing computational jobs and improving processing efficiency. The objectives of our project are number one, Google Cloud simultaneous image processing reduces processing time. Spreading photo processing over several virtual computers or containers speeds things up. Our second objective is Google Cloud Scalability offers flexible task management and effective image data processing, dynamic resource allocation, and infrastructure scalability, optimize resource use, and picture processing at any size. Lastly, Google Cloud simultaneously processes image, allowing real-time or near real-time photo analysis. Video streaming, surveillance, and real-time image-based decision-making needs fast image analysis. This is the literature review. The literature review demonstrates the benefits of Google Cloud's distributed image processing in computer vision, medical imaging, digital photography, and video processing domains. Parallel computing and scalability addresses these challenges related to large data sets and real-time processing. Efficient resource allocation, containerization, and pre-trained models further help to optimize image processing workflows. Therefore, practical implementations and case studies validate the effectiveness of Google Cloud's distributed image processing, enabling faster processing times and real-time or near real-time analysis. Moving on to the research methodology used in our project. So first of all, the experimental design, implementing and evaluating parallel image processing algorithms on Google Cloud, and developing code, configuring cloud resources, and conducting experiments. For sample images or datasets, we have selected based on factors such as size, variety, complexity, and real-world representation. Sourcing existing image datasets or capturing and pre-processing images specifically for the research. Collecting relevant data from articles, journals, and theses related to parallel image processing. Configuration of Google Cloud resources, setting up compute engine instances for parallel image processing, determining the number of instances and their specifications based on experimental requirements. Detailed steps of image processing algorithm, pre-processing, feature extraction, image manipulation, or other relevant operations, and also dividing the algorithm into smaller tasks for parallel execution on multiple instances in the cloud. The measurements of system effectiveness, processing time scalability, which is the performance with increasing workload or resources, and resource utilization, which includes CPU, memory, network. And last but not the least, evaluating efficiency, speed, and effectiveness of parallel image processing on Google Cloud.
Anticipated result: improved processing speed and reduced execution time due to parallelism. By using Google Cloud's distribution computing capabilities, parallel images processing allows for the concurrent execution of several tasks or operations or various aspects of a single picture or set of images. Higher scalability, enabling the handling of larger image datasets. By distributing the workload among a number of computational resources such as virtual machines or containers, parallel image processing enables effective scalability dependent on the size and complexity of the picture collection. The analysis of massive picture collections or real-time image stream is made easier by the system's capacity to scale without guarantees that it can meet growing processing needs as the dataset expands. Uh, Analysis and interpretation, computing processing times, calculate the speed up attending by parallelism to assess the efficacy of parallel approaches. Consider elements like the size of the picture collections, the complexity of the processing jobs, and the quantity of computer resources used. Impact on image quality measures. Examine how parallelism affects different pictures quality metrics such as noise reduction, image uh, augmentations, or feature extractions. Compare the outcomes of sequential processing to those produced by parallel processing. Limitations and challenges. Limitations of parallel strategies selected. Some image processing jobs or techniques may not be amenable to parallelization, leading to subpar speed up or restricted scalability. Talk about any difficulties encountered while converting algorithms or jobs to parallel computing environment and how they affected the project as a whole. Challenges with data pretreatment and transfer. While preparing data before parallel executions such as data cleaning, formatting, or resizing, discuss the effects of these difficulties on resources usage and processing time as a whole, address any concerns with data transfer efficiency that may arise, taking into accounting things like data size, network latency, and synchronizations problem.
Next, we convert the blurred images to grayscale using cv2 color. After that, we perform the edge detection using the canny edge detection algorithm with cv2.canny. We also simulate some processing time with time.sleep. We create the output path by combining the output directory and the image name using os.path.base name and ospath.join. Finally, we save the processed image to the output directory using cv2.imwrite. If the processing is successful, then the function returns true, and if some error occurs, we catch the exception, print an error message, and return false. Then we create a list of images from the input directory. We use os.listdir to list all the files in the directory and filter them to include only JPEG and PNG files. We construct the full path for each image using os.path.join. Then we create a threadful executor to manage the parallel execution of the image processing task. Then we initialize an empty list called results to store the future objects representing the execution of the task. Here we set up a progress bar using TQDM to track the progress of the image processing. The progress bar is initialized with the total number of images and a description. After that, we iterate over each image. After this, we iterate over each image path in the list. For each image, we submit the process image function to the executor for parallel execution using executor.submit. We add a callback function to update the progress bar for each time a task completes using feature.addOn callback. We append the feature object to the results list. After submitting all the tasks, we shut down the executor using executor.shutdown wait equal to true, which waits for all the tasks to complete before proceeding. And finally, we calculate the number of successful and failed images processing tasks. We use result.result to retrieve the result for each future object. We sum up the successful results and uh, calculate the number of failed tasks by subtracting the successful count minus the total number of tasks. After that, we print total number of successful and failed tasks. Now, I'm going to run or execute this whole code for our image processing. As you can see here, we have a few images which we took as input, and we'll have the output here in this folder. So okay, so here we have our output. So we have successful 7, failed 0. So the this whole Python code has successfully executed the image processing with 0 failure. And now if you want to check the outputs, these were the previous images, I mean the input images here, and here these are the output images. As you can see, we have successfully processed the images with this code. That's all from me. Thank you.